Hello my dear young friends, beloved students, welcome back to C-Level Physics. My name is Srinivas. Today I want to share some numericals related to NEET, JEE Main and Advanced. Okay, let's move on to discuss. First one, here, find the time taken by an oblique projectile which is projected from the ground to move perpendicular to the initial direction of motion. Okay, so here how to draw one oblique projectile. So this is what oblique projectile, right? Oblique projectile. Now what is the velocity of projection here? Velocity of projection, let be velocity of projection, let be u, right? This is what u, which makes an angle theta with horizon, right? Now this is the position reached by the projectile, right? Say this point P on the path, at which what is the instantaneous velocity here, let be v, like that. See this what v, right? V. If I extend this vector behind like that, see, it means somewhere, see. Now what is the angle between u bar and v bar? Perpendicular, that is 90 degrees. See, both u bar and v bar are perpendicular to each other. That means to say that this is the position, right, reached by the projectile at which it moves perpendicular to the initial direction of motion. See, u bar means this is what initial direction of motion. This is the direction of motion by the time when it reaches position P. So here, when it reaches position P, it moves perpendicular to the, see here, what is the angle? 90 degrees, perpendicular to the initial direction of motion, right? Now what is the time taken by the projectile to reach P from O, such that to move perpendicular to the initial direction of motion? Now what is the time taken by the projectile to go from O to P? Here what is the time? Time is unknown here. What is the time to reach P from O? Right? At point P, it moves, see this is what direction of motion. It moves right angles to the initial direction of motion. Right? For that, what I am doing means here, I am extending, see, I am extending this vector onto x-axis line. Okay, onto x-axis, right? Now what is the angle here? See, this is what right angle triangle. Right angled triangle. Here 90 degrees, here theta. Definitely here 90 minus theta. 90 minus theta. 90 minus theta. Am I right? Okay. Right? Now here also, at point P also I am resolving V into two components. One is along X, another one is along Y. Like along Y. Right? So this is what Vy. This is what Vx. Here, this is what Ux. Here, Uy. So what is angle made by U with the horizontal, that is theta. So this is what Ux, U cos theta. Adjacent side, U cos theta. Here it is Uy. So U sin theta. So these are the components for initial velocity at point O. Now, what about the components of V at P? That is along X, along Y. If you want to know these two components, so how to specify angle somewhere here, otherwise I am interested in taking here. See, this is what theta, some theta. Why? Because here it is what is angle 90. See, here one more right angle triangle here. So here 90 degrees. See these two perpendicular to each other. So 90 degrees. Here it is 90 minus theta. So definitely this is theta. Right, 90 minus theta, 90, here it is theta. Okay, so here velocity at P is lying in fourth quadrant. So it finds two components along Vx, along Vy. What is Vy here? See, this is adjacent side as far as V is concerned. So therefore Vy equal to V cos theta. V cos theta. V cos. Now what is Vx? That is V sin theta. V sin. Okay, this velocity finds V cos theta along adjacent, V sin theta along horizontal. So see, this is what horizontal. So here this is also argent, right? So Vx equal to V sin theta. Okay. So as you know very well, there is no horizontal acceleration. Why? Because there is no force along horizontal. So Ax, suppose this is what Ax, this is what Ay. What is Ax? 0. There is no acceleration for the projectile along horizontal since there is no force along horizontal. Now coming to Ay, what is Ay? Minus G from sign convention. Why? Because G is always acting downwards. So here it is minus G. Right? So as there is an acceleration along horizontal component remains same throughout the motion. So here what is horizontal component? U cos theta. Here also must be U cos theta. See here V sin theta, that must be equal to U cos theta. Why? Because there is no force along horizontal. So what is the point? That is Vx at P must be equal to Ux at O. So Ux at O must be equal to Vx at P. Why? Because horizontal component remains same. Vx at P means what? V sin theta. V sin theta equal to Ux at O. What is Ux at O? That is U cos theta. U cos theta. Alright. That is V equal to U cot theta. So we came to know that the speed of projectile by that time when it moves right angles to the initial direction of motion, right? So at point P, what is the speed? What is the speed here? U cot. U means velocity of projection, theta means angular projection. OP, take V equal to U plus AT along vertical. Why? Because here we have Uy, U sin theta. Here we have Vy, V cos theta. Ay equal to minus G. Now time from O to P is unknown. That's what we need to find ultimately. Okay. So V equal to U plus AT along vertical from OP for O to P segment O to P, right? Now what is V by V cos theta? But here it is downwards, so minus V cos theta. Minus V cos theta equal to Uy. Uy means U sin theta upwards, so positive. U sin theta plus Ay. Ay means what? Minus G. Minus G into T. Time unknown. Now minus V. V means what? U cot theta. V means speed at the point P. That is U cot theta. U cot theta into cos theta. That is U sin theta minus GT. That is minus U cot theta means cos theta by sin theta. Cos theta by sin theta into cos theta means cos square theta. That is equal to U sin theta minus G. That is minus U cos square theta equal to, carry this sin theta onto RHS, that is U into sin theta and sin theta, sin square theta minus GT into sin theta, GT sin theta. Right? Now make it subject minus GT sin theta. So I'm taking this side, it becomes positive, that is GT sin theta equal to here U sin square theta. Now send this minus U cos square theta onto RHS, that is it becomes positive, that is plus U cos square, right? That is GT sin theta equal to U of cos sin square theta plus cos square. Sin square theta plus cos square theta is 1. See, this is what? Number 1. Sin square theta plus cos square theta equal to 1. So we left with T equal to, what is T? U by G sin. So this is the time after which projectile moves perpendicular to initial direction of motion. So at that position, what is the speed of the projectile? U cot theta. U means speed of projection, Theta means angle of projection. So coming to numerical, suppose here u equal to 10 meter per second, for example, u 10 meter per second, g 10 meter per second square. Now find the time. Here theta 30 degrees. Here theta, that is 30 degrees. Now for this projectile with this numerals, find the time after which it moves perpendicular to the initial direction motion is t equal to u by g sine. Now what is u? U means 10 meter per second divided by g, take it as 10, g 10 into sine theta. Sine theta is sine 30, that is sine 30 into sine 30. 10 cancel, that is 1 by sine 30 means 1 by 2, 1 by 2, that is 1 by 1 by 2 means 2. So 2 seconds is the answer. So after 2 seconds, this projectile with this angular projection moves perpendicular to the initial direction of motion. Very simple. A shortcut form. So what is the speed at that instant? At this instant, what is the speed? That is u cot theta. U means what? 10 meter per second into cot theta. Cot tan 30 means 1 by root 3. Cot 30 means that is root 10 root 3. That is 10 root 3 meter per second. This is the speed of the projectile when it moves right angles to the initial direction of motion. When it is projected from the level ground. Right? Okay. Now coming to next one. This time body is projected, not projected from the ground. It is projected from some elevation like. See? This is what some elevation like. Something like tower. From the top of this tower, body is projected with some initial velocity u, such that making an angle theta with horse. Right? In that case, what is the expression for range? What is the expression for time of flight? Let us see. Right? Means body projected some initial velocity, making an angle theta with horizontal, but not from the level ground. That is projected from the top of one tower. Okay. Right. Now see here. See from this tower. From this tower is what one tower like that. Height h is what height h. Now this is what top of the tower. From this top, one body is projected with some initial velocity u, such that making an angle theta with horizon. Right? Now this is what level of projection. Level of projection. Now it takes parabolic path because of gravity and reaches level of projection. Level of projection and continues to move below the level of projection until it strikes the ground line. See this what? Ground. Okay. Strikes the ground somewhere. Now take some labels. This is what point of projection O. This is what highest point A. This is what point B, which is at the same level as that of point of projection. Now this is what point C, on the ground at which it strikes, right? Now OABC. Here U can be resolved into two components. Usually that is Ux equal to U cos theta. Here Uy, that is U sin theta. Usual projections. Usual components otherwise. U cos theta, U sin theta for U. Right? So what is the time taken by the projectile to reach B? Now time from O to B, is it time of flight? No, it's not time of flight. Why? Because beyond point B it moves, it continues to move until it strikes the ground. So the time for O to B is not the time of flight. The time for entire segment, that is O to C, is the time of flight. Of course, what is the time from O to B? That is here T equal to 2U sin theta by G. 2u sin theta by g, which is not equal to time of flight. Of course, what is the time taken by the projectile to reach B, which is at same level as the point of projection, is 2u sin theta by g only, which is not equal to time of flight. Now what is the range? Now horizontal distance from O to B, is it range? From O to B, is it range? It couldn't be range. But the distance from O to B along horizontal must be equal to, say this what? Sx for example, that is 2ux uy by g. That is 2u cos theta u sin theta by g1 from O to B, but not equal to range. But not equal to range. Now what is range? This is what range. This is the range. Right? So here body continues to move beyond the level of projection until it strikes the ground. Now this is what total horizontal distance or total horizontal displacement covered by the body in entire flight. So this must be range. It's not equal to range. This is not equal to range. So OB equal to 2ux uy by g, that is u square sin 2 theta by g, but not equal to range, right? Okay. Now how to find range? How to find range? How to find time of flight? It's not time of flight, as I said. Now what are the coordinates on reaching C and NC? What is the horizontal component? R, right? Horizontal distance, that is the x component. X coordinate, that is x coordinate is R. What is the y coordinate here? Y means, see, this is what point of projection. This is the final position. This is the initial position. This is the final position, right? Like that. This is what displacement in fact. But it is divided into two components, Sx, Sy. This is the vertical displacement. Am I right? See, this is the initial position. This is the final position at which it lands on the ground. So a line segment drawn from initial to final. This is the displacement, which can be resolved into two components, along x, along y. So along y means from here to there. So h be the vertical displacement covered with the negative sign. Why? Because this is the point of projection. Now vertical displacement means from the point of projection downwards. So this is what? Minus h. Y coordinate minus h. Minus h. See, this is what displacement. This is what horizontal component of displacement. That is 2ex by g. Sorry. This is what horizontal component. This is what vertical component. Vertical component means h with negative sign. So x coordinate or y coordinate minus h. Minus h. Right? Okay. This is what height. H. For the term. Okay. Now, how to find range? Range. Right. What is the expression of range? S equal to ut plus of h square. Ut plus of h square. Take this expression along x-axis. Ux to h. Sx. Sx means this one, not this one. Okay. Right? Sx. An entire flight. What is Sx? R. Right? That is ux means what? U cos theta. U cos theta. What is time? T equal to capital T. Time of flight. Here this is what? T equal to capital T. To reach position C. Right? So plus U cos theta into capital T plus half into Ax means 0. There is no acceleration along x. So into T square. What is T? Capital T. So R equal to U cos theta into T. So range equal to U cos theta into capital T. Capital T. So what is T? Time of flight. What is T? Time of flight. How to find time of flight means you take the same expression along y-axis. So we know that S equal to ut plus of at square. Take the same expression along y-axis. Right? Now what is Sy in entire flight? This is the vertical displacement covered from this position to this position. That is h with negative sign. Minus h. Uy means u sin theta upwards means positive. u sin theta into capital T into capital T. P means entire flight means T becomes capital T, time of flight. Plus half into ay means minus g into capital T. Okay. So on solving this expression, one can find capital T. So this is the expression to find time of flight. From this expression, on finding time of flight, we can substitute T here to find horizontal range. Horizontal range. Coming to a numeral. See here, one numerical. What is u? U means 30 meters per second. What is theta? 30 degrees. What is height of the tower? 20 meter. 20 meter. Now, in this case, find range as well as time of flight. Time of flight. Now see, what is range here? This is what range. Want to know that range, before finding or you need to find time of flight. Substitute here. Minus h means what? 20 equal u sin theta. U means what? 30 into sin theta means sin 30 into capital T unknown, plus or minus half into g means 10, for example, t square unknown. That is minus 20 equal to 30 into sin 30 1 by 2 capital T minus 5t square, 10 by 2 5. Okay, that is minus 20 equal to 30 by 2 15t minus 5t square. Cancel 5 on both sides, that is minus 4 equal to 3t minus t square. Now t square minus 3t minus 4 equals, right? This is what? Ax square plus bx plus c form. Here a means 1, b means minus 3, c means minus 2. Now what is t? Minus b plus or minus root over b square minus 4ac by 2a. Right? That is t equal to minus b is 3 plus or minus root over b square minus 4ac. b square minus 3 square 9 minus 4 into a 1 c minus 4 by 2a 2 into 1. That is t means what? 3 plus or minus or minus plus 4 4 is 16 plus 9 root 25, that is 5, right? So t finds two values, 3 plus 5 by 2, 3 minus 5 by 2. 3 plus 5 by 2 means 8 by 2, that is 4 seconds. One more root, 3 minus 5 by 2, that is minus 2 seconds. Minus 2. I have never been negative, therefore minus 2 seconds the wrong option. This is right option. What is the time of flight here? 4 seconds is the correct time of flight. 4 seconds. And with positive sign. I have never been negative, so therefore negative value ruled out. Okay. So this is what time of flight. 4 seconds. So what is the time taken by this projectile to reach ground? Means from here to there to reach C on the ground. What is the time taken? 4 seconds. Now what is the range covered here? Horizontal range means u cos theta into t. Substitute here u cos theta. Range means u cos theta. U means 30. Cos theta, cos 30. Cos 30 means root 3 by 2 into time of flight 4 seconds. 4 seconds is the right answer. That is 4 seconds. Right? That is 4 by 2. 2 into 30. That is 60. 60 root 3 meters is the right answer for horizontal range. So its range is 60 root 3. Time of flight is 4 seconds. Right? So once again, time to reach B through A. It's not time of flight. It's not time of flight. This is the time of flight. It's not range. This is the range. Of course, if you want to get time to reach B, you can take 2u sin theta by g, which is general expression in case of body projected from the ground. Right? Okay. Now in the same case, I want to know for what angle range becomes matched. Right angle of projection, range becomes matched. Suppose if the same body is projected from the ground with some angle theta, so for a given velocity, for a given speed of projection, if theta is 45 degrees, range becomes maximum at a given place. Okay, here, what is the angle at which it finds maximum range? When it is projected from top of one tower or from some elevation. So even in that case also, there exists one angle for a given speed of projection at a given place to have maximum range. Okay, so this time I want to explain that point. Okay. Right? If you want to get that point, is for what angle of projection here? For what angle of projection, range becomes matched. See question. In this case, when it is projected from some elevation, for what angle of projection, range is matched. For what angle of projection, for what angle of projection, range is maximum in above case. Of course, your body is projected at 30, right? But range may not be maximum for this 30. There exists some angle. You need to find that angle, right? So if you want to get this point, you have to consider general equation of trajectory. What is the general equation of trajectory? Y equal to tan theta x minus g by 2u square cos square theta into x square. Now, on reaching C in entire flight, this is the last point in its journey. So, what are the coordinates here? X coordinate or y coordinate minus h. Substitute C r comma minus h. R comma minus h implies x equal to r, y equal to minus h. Substitute the same values in above expression. That is, y means what? Minus h. Minus h equal to tan theta into x. X means what? X means r. Minus g by 2u square cos square theta into x square. X means what again? X means r. X square means r square into r square. Okay. So minus h equal to tan theta minus g by 2u square cos square theta into r square. Suppose if I differentiate with respect to theta, why? Because we are going to find angle of projection for which range becomes matched, right? So I am differentiating entire expression with respect to theta. Differentiate with respect to theta. That is minus dh by d theta equal to d by d theta of tan theta. Okay, that is tan theta is constant. D by d theta of r means dr by d theta, right? Plus differentiation of uv, d of uv means uv dash plus vu dash. Am I right? So take that expression, that is tan theta into dr by d theta plus this time r is constant. D by d theta of tan theta means secant square theta, right? Minus here g by 2 square cos square theta is constant, for example. Now differentiate r square with respect to theta, that is g by 2u square cos square theta into d by d theta of r square means 2r into dr by d theta. I am taking bracket here, bracket plus this time r square is constant. R square is constant. Now differentiate this term, first term, that is g by 2u square constant, g by 2u square constant. 1 by cos square theta means secant square theta. D by d theta of secant square theta means secant square theta into tan. 2 secant square theta into tan. 2 secant square theta into tan theta. Right? Okay. So once again, minus dh by d theta. Here see uv form. So u is constant, take differentiation of v. Plus v is constant, take differentiation of u. Similarly here also. This is what u, this is what v. So take u as constant, differentiate r square, that is 2r into dr by d theta. Plus this time take r square as constant, g by 2 square also constant, 1 by cos square theta, that is secant square theta. Take differentiation, that is 2 secant square theta. Right? Now what is dh by d theta? Height of the tower. Will it change with angular projection? No. So therefore dh by d theta is 0. 0 equal to, what about tan theta? What about tan theta constant? Dr by d theta? Dr by d theta, differentiation of range with respect to tan. That is dr by d theta. Again 0. Why? Because suppose if I have variation of r with theta like that. See here range is maximum for this theta, for example, right? So this is what variation of r versus theta. For this, especially for this theta, range is maximum, at which what is the slope of r theta curve? That is dr by d theta, slope is 0, right? So at maximum or minimum, what is the differentiation? That is, here it is dr by d theta must be 0. Why? Because here r varies with the theta as follows. Here it finds maximum range against this theta. So at which range is maximum? What is the slope? That is dr by d theta 0. So we are searching for angle for which range is maximum. Therefore, when range is maximum, dr by d theta must be 0. So dr by d theta 0. Right? This is what? 0. So this is what? 0. Right? Here also dr by d theta 0. Right? 0 like that. Here also dh by d theta 0. Okay. Now take the same values like that. Now minus dh by d theta 0 equal to this term 0 into something 0 plus r secant square theta minus here dr by d theta 0, therefore 0 here, minus of plus minus now take this expression, that is what 2 to cancel, right? We left with r square g by u square, right? U square. Here secant square theta, tan theta. Secant square theta 1 by cos square theta, right? 1 by cos square theta. Otherwise secant square theta like this. Secant square theta tan. Okay. So here 0 equal 0 plus r secant square theta minus 0 minus so and so. Right? Now take this term on LHS, that is r minus becomes plus, that is r square g secant square theta tan theta by u square equal to r secant square, right? Make it subject this term, that is negative term becomes positive, that is plus r square g secant square theta tan theta by u square equal to r secant square theta. Now secant square theta cancel. 1 r also cancel. Now make it subject r. That is r equal to, what is r? R equal to u square by g tan theta. U square by g tan. Is it ordinary r or maximum r? Maximum range. Why? Because here dr by d theta 0, at which range is maximum. So here dr by d theta becomes 0 means definitely this is r max, or otherwise r max. Okay, r max. Now for this numerals, Here u is 30 degrees, angular projection 30 degrees, sorry, u is 30 meters per second, angular projection is 30 degrees, height of the tower is 20 meters. When it is projected from this top of the tower, now find R max means R max becomes equal for this numerals, R max equal to u square means 30 into 30 by g tan theta. For example, g is 10 meters per second square into tan theta, tan 30 1 by root 3, that is 0 cancel, 3 into 30 90, 1 by root 3 root 3, so 90 root 3. This is what R max meters, for example. Entire values are in SI, so R also maximum range also meters, that is 90 root 3 is the right answer. Okay, so that's how one can find maximum range. So what is okay, that's what maximum range, right? Okay. Here we have maximum range. What is the maximum range? R max equal to u square by g tan theta. Here minus h equals so and so. Say this one number 1. Here in this expression, if R is replaced by R max, you can find theta also. Means angular projection for which range is maximum. Okay, that's how we can find angular projection also. So I am replacing R by writing u square by g tan theta. Okay. Now what is minus h? Minus h equal to tan theta into R. R means R max. R max means u square by g tan minus g by 2 u square cos square theta into R square. R square means R max whole square, that is u square by g tan theta whole square. So u square by g tan theta whole square, right? That is minus h equal to tan theta cancel. We left with u square by g minus g by 2 u square. Here g by 2 u square cos square theta into u square whole square means u power 4 by g square into tan square theta. Tan square theta means sin square theta by cos square theta. Why to write like that means cos square theta cancel. Okay, that is minus h equal to u square by g minus here g by g square means g cancel, u square u power 4. So in numerator we left with u square by 2 g into sin square theta u square by 2g sin square theta. Am I right? Now make it subject. So what is R max? R max equal to u square by g tan theta, right? Okay. Now on extending here, suppose make it subject u square by 2g sin square theta, u square by 2g sin square theta equal to u square by g plus h. That is u square by 2g sin square theta equal to u square plus gh by g. Right? Now make it subject sin square theta. Take reciprocals, that is 2g, gg cancel here, gg cancel. Take the reciprocals, that is 2 sin square theta by u square equal to 1 by u square plus gh, right? That is sin square theta can be written as sin square theta equal to u square by 2 into u square plus gh. U square plus g. This is what sine square theta in fact. Now take the root to get sine theta. That is sine theta equal to root over u square by 2 of u square plus gh. Now what is theta? Theta equal to sine square of root over u square by 2 into u square plus gh. This is what angular projection. This is what angular projection from the top of the tower at which range becomes max. For this numeral with u equal 30 and theta equal to with u equal 30, height equal 20, what is the angle exists for which range is max means replace here. For this coming numerical, that is theta. Theta means what? Theta equal to sine inverse root over u square. U square means 30 into 30. 30 into 30 divided by 2 into u square. Again 30 into 30, that is 900. 900 plus gh. What is h? 20. G means 10. 10 into 20. 200. 200. 200. Right? Like. That is theta equal to sine inverse root over 30 into 30 means 90. 90 by 2 means 30 into 30, 900 by 2. That is 450. 450 by 900 plus 200. That is 1100. 1100. That is 0, 0 cancel. Theta equal to sine inverse root over 45 by 110. 110. That is theta equal to sine inverse 45. 50 table, that is 9 by 50. Sorry, 9 by 22. 9 by 22. So theta equal to sine inverse 9 by 22. That's what the angle at the top of tower for this speed of projection, for this height at which range becomes maximum. What is that range? 90 root 3. 90 root 3 meter. Now itself have proved. Okay. Right? At a glance, some additional points on oblique projectile. Here, suppose a trolley which is moving with speed v. Here, one boy in the trolley throws one ball like that in the direction of motion of the trolley like that. Thus that making an angle theta with horizontal. Right? Now, what about the time of flight? What about maximum height? What about range? Let us see. Okay. Now if I resolve velocity into components here, see this is what initial velocity, this is what theta, it is ux, that is u cos theta, it is uy, it is u sin theta. Right? But what about v? It is stationary. The vehicle is stationary, no problem at all. So ux u cos theta, uy u sin theta. But here person is in contact with moving vehicle, so person also have some horizontal velocity. So until he releases ball also in contact with the person. So even ball also has horizontal velocity of vehicle. So what about horizontal component of velocity of ball here? Means u cos theta plus vehicle velocity, that is plus v line. Right? Now there is no effect on vertical component of velocity. Simply horizontal component only affects because of motion of the vehicle. Why? Because vehicle is moving rightwards. So we have to include velocity of vehicle to that horizontal component of ball, that is u cos theta plus v. So accordingly, what parameters changes here? See, what about time of flight equal to 2uy by g. U sin theta, no change. Usual formula 2u sin theta by g. Maximum height, that is uy square by 2g. That is u square sin square theta by 2g. No change. No change. No change. But range, what about range? Range equal to horizontal component into time of flight. What is horizontal component? U cos theta plus v. U cos theta plus v into time of flight 2uy by g. So this affects. So here in this case, motion of vehicle affects range, but there is no effect on time of flight and maximum height. For example, if the direction of motion of vehicle is leftwards, for example, not rightwards, leftwards, right? Now we have to include this velocity in the same direction, that is u cos theta minus v this time, not plus v, minus v. U cos theta, see, u is resolved into two components, one is u cos theta, another one is u sin theta, obviously. But here we have to include the velocity of vehicle in the same direction. What is the direction? Leftwards. So u cos theta rightwards, v leftwards. What is the net value of horizontal component? That is u cos theta minus v. So this time also there is no change in vertical component, that is uy sin theta. So uy, that is u sin theta. So there is no change in time of flight, there is no change in maximum height, but range changes. That is ux means u cos theta minus v into time of flight. Time of flight is 2uy by g. Right? Similarly, suppose if this is the frame from which this boy throws one ball like that, but here this reference frame, otherwise frame, moves upwards with some constant velocity, right? This time, how can you resolve velocity of projection of the ball into two components? See, u can resolve into ux, that is u cos theta. So there is no horizontal velocity for the reference frame, right? So simply u cos theta. Now what about vertical component? That is u sin theta plus v also. V means upwards. So u sin theta plus v. We have to include velocity of frame in that direction. That is u sin theta plus v. So this time vertical component affects by the motion of the frame. See, there is no effect on horizontal component. There is effect on vertical component. So what about time of flight? 2uy by g. Uy means u sin theta plus v. So affects. This affects. Time of flight affects. Maximum height uy square by 2g. So uy changes. Therefore uy also changes. So maximum height also changes. Affects. That is uy square by 2g means u sin theta plus v by u sin theta plus v whole square by 2g. Now what about range? Range equal to horizontal component into time of flight. Of course, there is no effect on horizontal component, but there is some effect on. See this word ux. No change. U cos theta. Right? No effect on ux, but at time of flight there is some effect because of change in uy. So time of flight affects. So in this case, particularly in this case, all the 3 points is affect, right? That is p equal to 2uy by g changes, maximum uy square by 2g also changes, range ux, even though ux remains same, but time of flight changes because of change of uy. So all the 3 quantities changes because of vertical motion of frame. If at all this frame is moving downwards with the constant velocity, like right, from this vertically moving frame, this boy throws one ball like that. Now this time u sin theta upwards, u cos theta rightwards, but here v is downwards, so we have to subtract v from u sin theta, that is u sin theta minus v. U sin theta upwards but v downwards. So as a whole, vertical component of velocity decreases, u sin theta minus v this time. So what about time of flight changes? Why? Because uy changes, maximum height also changes, range also changes. Of course u cos theta constant, but time of flight changes because of change in vertical component of velocity. So that's how all the factors will be affected by this downward motion of reference frame. Alright? So based on these points, let us examine one numerical. What is that? When a truck is moving at a speed v, see this is what one truck is moving at a speed v, and from the truck a boy throws two balls. See, this is nothing but one boy throws two balls like that. One in direction of motion of truck and another in opposite direction at same angle with the same speed u with respect to truck. See here, truck is moving rightwards with constant speed v. From this moving truck, one boy throws two balls with the same speed u at same angle of projection theta with horizontal but different directions. One is in the direction of motion of the truck, another one is opposite to the direction of motion of the truck, right, as shown. Now, range is covered by both balls are R1 and R2 respectively. See, this is the range covered by this ball. This is the range covered by this ball, right? R1, R2 respectively. These are ranges. Find the projection angle of balls in reference frame of truck. So here we need to find the angle of projection of balls. What is the angle of projection? See, here also theta, here also theta. So theta is unknown here. Theta is unknown, right? Theta is unknown. Now try to resolve velocity of projections into components. See here. See, first ball is projected in first quadrant, second one is projected in second quadrant. See, this is what first ball projected in first quadrant with speed u. It is theta. Now what about horizontal component, that is ux equal to u cos theta plus v. We have to include velocity of truck also. What is the direction of velocity of truck? Rightwards. So plus v. What about vertical component uy equal to u sin theta, right? Now coming to second one. See this what second one. This is what first one. This is what first one, right? Okay, now second one. See what is the speed of projection here? U. What is the angle of projection? Theta. So try to resolve into components. One is ux. Ux means what? U cos theta. U cos theta. Right? Now we have to include velocity of vehicle also. What is the direction of velocity of vehicle? Rightwards with v. So rightwards means that is opposite to u cos theta. So u cos theta minus v. Why? Because u cos theta leftwards but v is rightwards. So net value u cos theta minus v. Okay. For first projection here, u cos theta rightwards, v also rightwards. So u cos theta plus v here. Here u cos theta minus v. So this is what first one. This is what second one. Second one, like that. So here, what about vertical component? In both cases, u sin theta 1. So there is no effect on vertical component of velocity. Why? Because for both projections, what ui are nothing but u sin theta 1. But there is some change in horizontal components of velocity. One is u cos theta plus v. Another one is u cos theta minus v. Here positive sign is there. Therefore range more. Here negative sign is there. Here u cos theta minus v means somewhat less than this one. So here ux is more, here ux is small. So this large increase in ux, there is some maximum range than this one. Right? Now coming to calculation. What is the question here? To find the projection angle for both balls. Angular projection. Right? So in both cases, what is the time of flight? T1 equal to T2 equal to, what is the expression? 2uy by g. Uy means u sin theta 1 for both. That is u sin theta. U sin theta by g. Right? So R1 means what? R1 equal to ux into T1. Horizontal component of velocity into time of flight. Why? Because along horizontal there is no acceleration. Simply distance equals speed into time. So horizontal distance R1 equal to horizontal component of velocity into time of flight. That is ux1 into T1. ux1. This is what ux1. This is what ux2. ux1 means u cos theta plus v. U cos theta plus v into time of flight. Time of flight means both same one. That is 2u sin theta by g. Right? 2u sin theta by g. Okay. Right? Now coming to R2. R2 means R2 equal to ux2 into t2. What is ux2? ux2 means u cos theta minus v. U cos theta minus v into t2. t2 or t1 both remains, that is 2u sin theta by g. 2u sin theta by g. Right? So from these expressions we need to find angular projection theta in terms of R1 and R2. Right? Now take R1 plus R2 first of all. R1 plus R2. R1 plus R2. See this term plus this term. Right? That is, here second term positive, here second term negative. Same terms. 2uv sin theta by g. Here also 2uv sin theta by g. So here it is positive, here it is negative. So second terms will cancel out. On taking sum. That is, we left with the first term only, both. That is 2u square. 2u into u. 2u square cos theta sin theta. Cos theta sin theta by g. By g. Again plus 2u square cos theta sin theta by g. So that is twice means 4u square. 4u square cos theta sin theta by g. I am taking sum. Similarly, I am taking difference, that is R1 minus R2. R1 minus R2. Why? Because R1 is greater than R2. Why? Because horizontal component for first projection is more than that of second projections. So definitely R1 is greater than R2. So R1 minus R2. See, R1 is this one, R2 is this one. I am taking negative sign for this one. That is R1 minus of this one. So minus or minus plus. So second terms will not cancel out, but first terms cancel this time. That is 2u square cos theta sin theta by g minus 2u square cos theta sin theta by g. First terms cancel out. We left with second terms. Right? So this one minus of this one means this is positive. This second term also positive. That is 2uv sin theta twice. That is 4uv sin theta by g. Right? 2uv sin theta by g plus 2uv sin theta by g. So same term twice. That is 4uv sin theta by g. Right? So here R1 plus R2 is so and so. Here R1 minus R2 is so and so. Here u square is there. Here u is there. So that's why this is what number 1. This is what number 2. Take 2 square by 1 implies 2 square means R1 minus R2 whole square by 1 means R1 plus R. R1 plus R. That is R1 minus R2 whole square means 16 u square v square sin square theta by g square. 16 u square v square sin square theta by g square. See here R1 minus R2 whole square by R1 plus R2 means R1 minus R2 whole square into 1 by R1 plus R into 1 by R1 plus R2 means take the reciprocal, that is g by 4 u square cos theta sin theta. Sin theta, right? Okay, right? So here g by g square, we left with 1g. Sin square theta, sin theta, we left with sin theta by cos theta, means tan theta. So here 16 by 4. See here R1 minus R2 whole square by R1 plus R2 equal to 16 by 4, that is 4. U square cancel. We left with v square here. 16 by 4 means 4. 4v square. Sin square theta, sin theta cancel. We left with sin theta. Sin theta by cos theta. Tan theta by g. G square means we left with g. That is g. Right? So 4u square over cos theta. Sin theta by cos theta tan. Okay, so 4 v square sin theta by g. This is what? R1 minus R2 whole square by R1 plus R2, that is 4v square by g tan. Now tan theta equal implies tan theta, make it subject tan theta. Tan theta equal to g by 4v square into R1 minus R2 whole square by R1 plus R2. Right? This is what tan theta implies. Theta equal to tan inverse of g by 4v square into R1 minus R2 whole square by R1 plus R. This is what? Angle of projection for both balls. Theta equal to tan inverse of g by 4v square of R1 minus R2 whole square by R1 plus R2. Right? So, okay friends. Thanks for watching.